Hello, everyone, and good afternoon again. Please sign into the discussion forum for week 8 and post any questions you may have there. And let's get started with today's lesson. Okay, so introducing a new topic today. So we're going to be talking about about factoring. Okay, factoring is the topic of the day. We're going to see what that is, and we're going to learn how to factor expressions.
Isn't it a factor with the exclamation mark?
I'm sorry, say that again?
Isn't it a factor with an explanation mark, like number and the
Oh, no,
explanation mark?
that's factorial. That's
Oh yeah.
Okay, you talk about something like this. That's factorial, for example.
Oh
Factorial
yeah.
is 5 times 4 times 3 and so on. Today we're talking about factoring. It's a bit different. Okay, so let's first define the topic here. So definition of factoring. So factoring is a really important and a very useful tool in algebra. It helps us do a lot of things, including simplifying complex expressions, multiplying expressions with polynomials, also solving quadratic equations and higher degree equations. So throughout this course, we're going to be involved in factoring directly or indirectly. And it's also based on the rules of exponents. So we talked about the rules of exponents earlier this semester. So it helps if you review those rules because they're used here in factoring. So the easiest way to define factoring is to go backwards. Let's say we have 2 and we have x plus 4. Okay, that's an algebraic expression. What is this equal to? If we use the distributive property,
2x plus 8.
that's right, it would be 2 times x, which is 2x. 2 times 4, that's 8. This is what we call the distributive property of real numbers. So when we go from this stage to this one, we basically multiply or distribute. Distribute or multiply, technically the same thing. Okay, so factoring is basically the other way around. So when you go back from this form to this one, that's what we call factoring. So that's probably the easiest way to define factoring. It's just the opposite of multiplying or distributing. That's the whole thing about factoring, and we're going to talk about this in detail. We're going to see how to factor different expressions used in different ways. Another way to look at factoring is when you have, for example, some addition of 2 expressions, a and b, for example, x plus 1 here and 3x plus 2 here. So when you have an addition of terms, basically a binomial here or more. So factoring, another way to define it is turning additions and subtractions into some product, some multiplication, for example, c times d. So when you go from addition or subtraction to a product of factors, we also call that factoring. Okay, it could also be some subtraction. For example, you have j minus f, and somehow you turn that subtraction into some, let's say, k times h. Okay, whenever you take an expression with addition and subtraction, you turn that into a multiplication only or a product. We call that factoring. Here's a simple example. 15 is basically just a product of 3 and 5. So 15 is basically 3 times 5. We call these factors of 15. So 3 and 5 are factors of 15. Could be more numbers here if you could break it down more. For example, if you use 18, you can write 18 as 3 times 3 times 2. These also are called factors. You can see there's only multiplications between them, so we call these factors. So whenever you have a multiplication, the numbers involved are called factors. So basically, that's what we're going to be doing to expressions. We're going to take some algebraic expressions, and we'll be turning those into products, like I said here. Now, let's see how to go back from this expression back here. As I said, factoring is turning additions into multiplications. So we want to turn this addition into this multiplication that we had here, 2 times the parentheses. So let's call that an example. So 2x plus 8. This one here. Let's see how to turn it back into this. So we're going to factor it. See how to get this. So you look at the expression here. It's a binomial with 2 terms, 1 and 2. So basically when you factor, you find the common factors or the common expressions, variables and numbers between 2 terms or more. So we have 1 term and this is 1 term. So let's find the common factor. So what is the common factor between these 2 terms? Common.
Would it be 2?
That's right. So they both have 2. This has 2. This also has 2 because 8 is basically 2 times 4. So they both share a factor. They share a number that we call the common factor. So once you see that common number, you write it down first and see if there's anything else common between the 2 terms. There's nothing else common. X is not common. X is only here but not here. So that's the only thing common. That's what we call the common factor. Once you find it, you immediately open the parentheses. Now then what you do is, basically we're going to remove the 2 from both of these. We move it to the front, we open the parentheses, and we're going to rewrite these without the 2 because we factored it out. We factored out the 2 to the front. So if you remove the 2 from here, what's left in this expression? First term here, if you remove that 2 to the front, what's left?
You just do the x plus 8?
Just x, just x. And for this one, if you remove the 2 to the front, what's left?
4.
4. So 2 is a common factor. We move it to the front, and we have 4 left here. And that's how we go back from here to here. As you can see, that's the expression we started with, 2x plus 4 to x plus 4. And the other way to go back again to this, all you have to do is distribute or multiply. Okay, so it's kind of a circular operation. One leads to the other. So if you keep going, if you keep circling here, you distribute, you factor, you distribute, you're going to be going in a circle. So that's the whole idea of factoring. You take something and you turn it into a product, and you do that by finding the common factors. So as you can see here, so the 2 is common for the 2 numbers. That's why we moved it to the front, and we remove the 2 from the terms here. And when you say remove, the actual application or the actual operation here is division by 2. Division by whatever the common factor is. Once you find it, you write it out, you factor out the common factor, you write it first, you open the parentheses, and then you kind of divide both or all the other terms by 2. So if you divide this by 2, the 2 and 2 cancel out, you have x left. Then you divide this by 2, 2 and 2 cancel out, you end up with 4. So this is the factored form. Again, we turned an addition into a product of factors. The factors here are 2 times x plus 4. So we have some c times some d. D happens to be an expression in parentheses, and c happens to be 2. So you can call it, for example, a plus b. B in this case is 8. So that's what we mean by factoring. So we turn additions and subtractions into a product. Okay, does that make sense to everyone? Everybody, does that make sense?
Yes.
Yep.
Yes.
Better than last week.
Yes.
All right. So this is basically how we're going to be doing. Regardless of how many terms you have. You may have 2, you may have 10. The concept is the same. You just look for what's common between the term, and basically you factor that out. Let's look at another one here. Let's say you have 3 x to x and maybe negative 6x to the second. So we have 2 terms, binomial. So we want to turn this subtraction into something times something. Once you do that, we call that factoring, or a factored form, just like, for example, 3 times 5. And you do that again by finding the common stuff between the two. Could be a number, it could be a letter, it could be both, could be a whole expression or parentheses. Whatever you see common between the two, that's a common factor. You write that first, just like we did with the 2. You're going to write that first before opening the parentheses. Okay, start with the numbers. What do you see common between these two terms? What is common between these 2 terms? Just start with the numbers. Coefficient.
2 x, no, x, right?
What is common between these 2 terms?
X.
3?
What is it?
Is it 3?
3. That's right. We have 3 here. We also have 3 here because 6 is 3 times 2. Okay, that's good. So 3 is common. Anything else common between the 2?
The x.
The x. That's right. We have x here.
Yes. So it's gonna be x and the power 3, or
So basically we have x1 here and x2. So the common one, or the one that goes into both, is the lower one. Just like
okay.
3, for example, we have 3 and 6. They both share 3. Same thing here, x1 and x2. They both share the lower one, the lower power. That's what goes into both. So we're going to say x1. That's the
Also,
only,
you have to subtract it, Professor.
not subtract it, just take the lower one.
Okay.
And that's how you do the open parentheses, right? After
That's
that.
right. Then we open the parentheses. Again, look for the numbers. Find the highest number that can go into both these numbers. In this case, it's 3. Then you go into the x and see which one goes into both. Usually the lower one, the lower power is that they both share, because this one has x plus 1. This one also has x plus 1. You can say, so x2 is basically x1 times x1. So they both share this x1. And also they both have 3, because 6 is just 3 times 2. So they have 3, which we wrote here. You also have x1, which we wrote here. That's it. So this is our common factor. Okay, common factor. Nothing else common. If you have something else that's common, for example, a y, then you're going to write it here. In this case, that's all. Once you do that, once you find the common factor, so we moved it to the front. So we're going to remove it from both of these. And the way we remove it is by division, just like we did here. So you find the 2, divide this one by 2, you get x. Divide this one by 2, you get 4. So the operation is division. So we're going to basically rewrite these. We're going to divide both of them by this. So let's write the 2 terms again. 3x plus 1, 3x minus 6x to the second. Okay, just write the terms and divide each one of them by the common factor. So we're going to divide this by 3x. Also here by 3x. Once we simplify this, we're done. So we're going to rewrite this again. So it's 3x. Okay, open the parentheses. This is where we use, as I mentioned earlier, when we use the rules of exponents that we learned in the beginning of the semester. So what is 3x divided by 3x? In other words, a number divided by itself is
1.
3x to the power 2. No?
no, these
Oh,
just
it's divided.
same number divided by itself. Then minus
1.
we have 6 divided by 3. That's
2.
2.
Then we have x2 divided by x1. What do you do with the powers?
The,
So we subtract.
subtract it, yeah.
Exactly.
So
Subtract
it's going to be 2x, just 2x.
just 2x or x to the power 1, same thing.
Mm-hmm.
Okay, so remember this rule, I believe it was the second rule of the powers that we learned, so we subtract the powers. And that's it. This is your factored expression. You may skip this step if you want. With experience, you'll see that you could probably skip this and you can just write this right away. You do the subtractions, mentally and just write the result. Okay, so that's an example. Let's do another one. The same way, it doesn't matter how many terms you have. You may have, like I said, 3 or 4 or 5, 6 terms. It's always going to be the same thing. So let's do another example. Let's say 6x to maybe the second plus 12x to the third and possibly 15 maybe x. So we have a trinomial here that we are trying to factor. We're going to do this just like we did previously. So what do you do first again?
So first we're going to find the lowest number, so it's 6.
That's right. So we have 6 here, we have 12 and 15. So we're gonna see what's the common factor in all of them. In other words, what number goes into all of these numbers? And it has to be, it could be a couple of numbers. Let's see, if you do, let's use 18 here. Let's use 18 here. So
6.
what goes into 6, 12, and 18? 6 is one of them.
Six.
What else? What could go into those numbers? 2 is also a common factor. 3 is
3.
a common factor.
That's it.
2 and 3. All of them go into that. But which one we take?
2.
Not 2.
Don't we
6.
find the highest, which is 6?
That's
6.
right. Exactly. So we need the highest. That's what we call it. The greatest. Okay.
Okay.
So and choose 6. Okay, that's the highest one that goes into all these 3 factors, 6, 12, and 18. Then, do we have anything else common between those 3 terms?
The x.
X.
The x. So it has to be in all of them in order to be a common factor. If it's only here and not here, then it's not a common factor. Only 6 is. So with x2, we have x3, and we have x1. Which one do we take again as a common factor with the x's?
The x.
X1.
The x1.
x1. That's right. Always take the x with the lowest power of all the terms, because that's the one that goes into all of them. You don't want to take x2 because x2 goes here, but it does not go into x1. This one is bigger than x1. So only x1 is common. Then you open your parentheses right away. So this is what we call the GCF. Okay? The greatest common factor. The abbreviation we're going to be using from now on is GCF. The greatest common factor. So this is the GCF. Okay, what do we do now after you find the GCF?
We put 6x to the second power.
What is the operation here? What do we do with these 3 terms and the common factor? Like here. We need to
Distribute.
Divide.
divide. So we're going to write all these and divide each one of them by GCF. So let's write the whole expression again. 6x2 plus 12x minus 18 x1. Then again divide. So because the 6x going to be moved to the front, so we moved it to the front. It has to be removed from all these terms, and by removing it we mean divide by it. 6x plus 1 Then you just do your divisions and the expression will be.
Professor.
Yes.
Oh, it's 18. I thought it's 14x. Okay.
Here?
Yeah.
Yeah, that's 18.
Mhm.
So now we're going to divide. So 6x, one stays here, open the parentheses. And again, use the rules of exponents that we talked about before. 6 and 6 cancel each other out. They're gone. X2 by x1, again, will be x,
1.
x to the 1, that's right. Then 12 by 6,
2x to the power 2.
that's right. X3 over x1, subtract the powers will be x2. Finally here, so we have a negative,
Minus 3x.
that's right. And what happens to x1 and x1?
You don't need.
That's right, these cancel each other out. They're gone, there's no more x.
Mhm.
It's the same thing. It's a number divided by itself is 1. So it's like saying times 1. Well, you don't need that 1, just say 3 and close the parentheses. Whenever you divide x and x, y and y, and the powers are the same, just ignore them. They cancel each other out. It's 1. Okay? And that's basically it. So we turn this addition and subtraction into, as you can see, a product, some a times some b. This is some factor b. So 2 factors a and b. As we said earlier, the purpose of factoring is turning additions and subtractions into products or multiplications. That's exactly what we did here. Okay? So we had additions of terms, subtraction of terms, 3 terms. We turned that into a multiplication. So this is 6x times this factor here. As you can see, nothing else is common here. That's how you know you factored properly. If you don't find the right, if you don't use the right common factor, for example here, if you use 2 or 3 instead of 6, you will end up with a common number here still, and you have to factor again. So you need to factor completely until you don't have anything in common. So make sure after you factor, there's nothing common between these terms. X is not common because it's not here. The numbers are distinct. You have 2, 3, and 1 here, invisible 1. So that's how we know your factoring is done. Okay, does that make sense to everyone? Any questions at this point?
No.
Okay, again, this
No.
topic is very important, so make sure you understand it. It will make your life a lot easier in this class. All the future topics will be based on factoring, whether, like I said, directly or indirectly. So make sure you understand every step here. There are basically 2 main steps. Find the common thing and divide by that common thing. That's all you have to do. So find the common thing between all the terms. Then you gotta write that common thing and divide all the terms by that thing. It doesn't matter how many variables you have, how many terms you have, it's the same concept. Just see what's common between all the numbers. Then we're gonna be talking about another way or another type of factoring when you can't see a common factor in all the terms. Before that, let's do one more example. This time I'm going to use a couple of variables, not just one. So let's say 15, put xy here, plus maybe 35 xy. Let's do some powers to 3, maybe 4 here. So we have 2 terms here. Again, we want to turn this into a multiplication. So what do you do first? What's the GCF? What's the common factor?
15.
5? No, 15.
15.
15. What's common between 5 and 15?
10? No.
What's the common factor between 5 and 15? I mean 15 and 35.
So we have to.
That's a 5.
The 5, right? The
Yeah.
highest number is 5. That's common. What else is common between the two?
X
X's.
and Y.
That's right. We have x2.
Yes.
Which one do you take as a common factor?
X2.
That's right. Always take the lower power as a common factor. That's x2.
And Y1.
And just
Wait.
Y.
That's right. We have y3 and we have a y1 here, invisible one. So the one we're going to take is the y1 with the lower power.
And
Nothing else. You open the parentheses. Yes?
yeah, nothing. I just was listening.
So this is again what we call the GCF, the greatest common factor. The greatest common factor, as we mentioned earlier. Okay, what do you do next? So we find the LCD.
Then we're gonna divide 15.
We're going to divide all these two terms by this.
Oh, I mean 5.
So you could skip this step.
So it's going to be
You can divide-
3y2.
That's right. You can divide on the fly. If you may say, you can say this divided by this, or you can write it out first if you want. So let's divide this one by this. Start with the numbers. You have 15 by 5.
Yeah,
It's
so
gonna
it's,
be 3
That's right. Then you have x2 by
X2.
it's
Just
3y2.
one?
you cancel out. That's right. x2 by x2. Those cancel out. Just like
Mhm.
x1 and x1. So you don't have to write the x. Then we have y3 by y1, which will be,
Y2.
Y2.
that's right, y2. We subtract the powers just like here. Just going to say y2. That's right. Plus, and repeat the same thing. So we're going to divide this one again by the GCF. Start
So
with,
it's 7x2.
that's right, 35 by
7, yeah.
x4 by x2.
X2
That's right. Divide the
and just 1.
That's
I'm-
right. y1 by y1 cancel each other out, so we don't have to multiply. Just like here, they cancel each other out. They're gone. 18 by 6 is 3. No need to write anything else. Same thing here. y1 by y1 is just, you can think of it as times 1, but you don't need to write it. Just close the parentheses.
So I go.
See, we turned it into a product. So we have some a here. This term times this factor. We have a factor here times another factor. How do you check? How do you double check if you got the right factoring?
So we multiply 5 by 3, yeah?
That's right. You can distribute. If you
Yeah, and then 5 by 7, and then we just multiply x2 by...
Exactly. So if you distribute, you'll get back to this because factoring is the opposite again of multiplying. So you can always double check on the side. Use the distributive property. If you multiply, you should get exactly this. For example, 5 times 3, that's 15. x2 times, there's no x here, would be x2. Then you have y1 times y2 would be y3. So you can check that on the side if you want after you factor.
Mhm.
So that's what we call the GCF, or the greatest common factor. It doesn't matter how many variables, how many terms, it works the exact same way. Just be careful with your powers, subtract accordingly. Make sure you use the highest common factor or the greatest. Okay.
Professor is going to be on the midterm?
Everything we cover will be on the midterm, yes.
Oh.
So now we're going to see another case where even if you don't see a common factor here, for example, we can still turn the expression into a product. We can still factor even if you don't see a common factor. That method is called factoring by grouping. Okay, factoring by grouping is another way of factoring expressions. So let's say we have 5x plus maybe 5y plus ax plus ay. So this is a polynomial with 4 terms, 1, 2, 3, 4. We want to factor it. As always, we try to find the common factor. But do you see a common factor here for all these terms?
No.
That's right. Nothing is common between all these terms. 5 and 5 are only here, but they're not here. A and A are here, but not here. X is only in these two terms, and so on. But we can still factor using what we call factoring by grouping. That means we can split this into groups. And each group would be factored using a common factor like we did earlier. So basically what you do is you just ignore this or split it into two groups. So ignore this one for a moment and let's factor this the same way we just did. What is the common factor here again? What's the common factor?
5. In the first, it's 5, so it's 5 times x plus y.
Right? So once you find the common factor, you put it outside and you divide both by 5. If you divide this by 5, you have x left. Plus, if you divide this by 5, or if you move
Y.
you have y left. Okay, that's the first group done. So let's ignore this side now. Let's go back to this side and factor it.
Then A.
That's right. We see a here and here and here.
X plus Y.
That's right. So once you find the common factor, we're going to divide by a, or move the a to the front. So we have x left here plus y left.
Y.
Okay, so we had 1, 2, 3, 4 terms. How many terms do we have now? How many? 2. Only had 2 terms, so 1 term plus this term. Now, if you look at these two bigger terms, do they have a common factor? If so, what is it?
Oh,
One, right? No.
Say that again?
what was the question? I'm
What's
sorry.
common? What is the common thing or factor between these two terms? This one and this one.
X
Y.
and Y.
That's right, x plus y. The whole thing in parentheses is a common factor. So that's common in between the two. So again, once you find the GCF or the common factor, what do you do with it? Always move it to the front, right? Always move it to the front. So we're gonna move this to the front, x plus y. What comes right after the GCF? What do we write? Right after the common factor, we open the parentheses,
Right.
right? So find the common factor, you move it to the front, just like we did here in the previous examples. Every time you move the GCF, so this is GCF. You immediately open the parentheses, and then what is the operation now? What do we do with these two terms and the GCF? We
Divide.
like we did here, we're going to divide all of them by the GCF. So if you divide this term by the GCF, what is left? If you divide this by the GCF,
Just 5.
just 5. X plus y will cancel out, end up with 5. Plus, you do the same thing with the other term. We're going to take this term, again, divided by the GCF,
So plus A.
plus a. So x plus 1 crosses out. Look at it this way. If we divide this by x plus y, the GCF, so these two cancel out, end up with 5 by itself. That's why we have 5 here. Same way, divide these, we get a. As you can see, we turn additions into a product. So this is some a times b. Okay, that's the purpose of factoring, is turning additions and subtractions into products of factors. We're gonna see how this is very useful in the future. Once you turn an expression into like this, again, this helps simplify complex expressions. It also helps solve quadratic equations or third-degree equations, and also helps with dealing with what we're gonna talk about in the future, something called the rational expressions. Rational expressions, we're gonna see how to simplify them using basically factoring. So that's factoring by grouping. So if this doesn't work, if you don't see a GCF, then try to group your terms, factor each group by itself, and then at the end you may end up with a bigger common factor like this, which you move to the front and then divide to get your expression factor. So in this case, this is done, and that's our answer. everybody? Any questions about that example?
Nope. I'm still
Can we
trying to
just get another
figure.
one?
Yep, we're about to do another one. Okay, let's do something very close to this. So let's say we have maybe, say, cx on cy plus 3x minus 3y. You can see here we have 4 terms. Do we have a GCF? Do you see a GCF here?
No, we should group them. So it's going to be first group going to be cx minus y.
That's right. So we're going to group them. So again, split this. We virtually split that. Think of it as two
Professor, why can we do like, for example, so we have CX and 3X, so can we combine them? Because there's X and X.
That's actually, I think that's possible. You end up with the same result. If you prefer to group these two instead because they have X in common, these two together because they have Y.
Doesn't matter?
It doesn't matter. I think you will get this.
Oh, okay.
The only difference is, for example, if you factor one way, for example, we'll get A minus C, and let's say B plus, I don't know, D. If you factor one way, you get this. If you factor the other way, this will come first. For example, B. That's the only difference, but it's still the same expression. Yeah, it's the same thing. That's the only difference you'll see. But you can always feel free to rearrange the terms. So they're not always conveniently placed like this. So you may have to rearrange them. So they're not always conveniently placed like this for you to see, but sometimes they could be shuffled around. So you could rearrange them until you find groups that have something in common. Okay, so let's just do it in the order it was given. So we have C common here, so we're going to say C.
X minus Y.
So this one will be plus. The common is
3X minus Y.
X minus Y. As you can see, after factoring, now we have this common factor, X minus Y. Okay, what do you do next?
Then we're gonna divide by X minus Y, so it's gonna be C left.
What's the GCF between these two? The common factor?
X and Y.
X minus Y. That's really going to write X minus Y first. Then open the parentheses and divide both of these by the GCF. If you divide this by this, what's left? What's the quotient?
C plus 3.
C plus, that's right, divide this by this, you get 3 left. Again, once you turn your expression into a product, that's the purpose of the question, is to factor it or turn it into a product. The powers could be different here, it could be 1, 2, whatever, it could be some terms like these, but work your problem the exact same way. Just factor each group completely, make sure you use the highest number, use the right variable, usually the variable with the lowest power. If you factor your two groups, then you'll see something that's common. It could be, for example, 3x to the 4 minus 2y as a common factor. That's not a problem. If you see this in both expressions, then you do the same thing. You move it to the front. So that's how factoring by grouping works. Basically, do each group separately before you factor again and find a GCF. Any questions, everybody, about everything we've done so far?
Nope.
No.
All right, so you're going to see plenty of this in the examples. Let's do this example, if I may paste it here. Okay, good. that's another example of factoring by grouping. Here it's already one step ahead. We don't have this to go from here to here. It's already written like this. So what is the common factor here between these two?
Between one.
So we have one term minus another term. What's the GCF? Or what's the common thing between those two?
X. 2x.
Yeah, X.
X. 2x and minus 7.
Try, we have 2x minus 3, 2x minus 3. That's the common factor. Okay, so we're going to write that first. So we're going to write 2x minus 3. And immediately, once you write your GCF, you open the parentheses. So this is the GCF. Okay, now that we found the GCF, what do we do? We're going to divide both of these by the GCF. If you divide the first term by 2x minus 3, what's the result?
2x to the power 2, no?
Nope, we're dividing, so we're going to divide
Oh,
both of these by the GCF, which is 2x minus 3. 2x minus 3. Okay, so these cancel out. What's left is x plus 1. Here we have x plus 1 left. Then we have minus. And if you divide this by the GCF, the result is, we cancel these,
4x plus 7.
right? You have negative 4x plus 7. Close the bigger parentheses. Close these parentheses. Then you can try to simplify this inside a little bit. So we have 2x. 2x minus 3, and then we can combine like terms. So we have x. What's x minus 3x? 4 minus 4x, so it would be,
Minus 3x.
that's right. Then we have 1 minus 7. This is minus,
Minus 6.
that's right, it would be negative 6. And that's it. That's done. So this one was even easier than these because it was already basically in this stage. All I had to do was spot the GCF, write it first, and then divide the terms by the GCF, and then write what's left inside, and always try to simplify if possible. Here, 5 plus a can't simplify, c plus 3 can't simplify, but if you have other things that can be simplified, you can do that. So it could be written, these expressions can be written in different forms or whatever, but just look at them and see what's common. That's the GCF, move it to the front and divide. That's basically the concept of GCF. And again, you'll see plenty of examples in the homework. It may look a little different. Each question may look a little different, but again, the concept is the same. Just use the same steps, same concept we used here to factor any expression. So we saw factoring by grouping and factoring by using the GCF. We're going to learn a couple more methods in the by next class. We're going to see other methods of factoring. So when GCF doesn't work, that's usually what we try first. If it doesn't work, then we'll look for factoring by grouping if it's possible. If not, we do what we call binomial factoring and trinomial factoring. Those are special factoring methods that we're going to learn in the next class. Any questions, everybody? It's pretty much all for what we have to cover today. Do you guys have any questions about any of this?
No.
Nope.
Okay.
No, thank you.
Very good. So this is not a complex topic. It involves a little bit of powers. Make sure we review your rules of exponents. And a couple of steps, if not 3, every time, same concept. Okay, so I will upload this so you guys can rewatch it. I highly recommend that you rewatch it. Of course, the more you learn, practice makes perfect. Okay, so again, reminder, the midterm is next week on Wednesday. We're gonna have a review on Monday, next Monday. So work on the review sheet, which is posted to the drive, to the homework folder. So work on that, write down any questions. So as we go, so we covered one more topic from that review sheet. We're probably gonna cover one more next class. And stuff that we haven't covered will not be included. So do not worry about the stuff in the review sheet that's not covered yet. That will be left.
So where's the review sheet?
It's in the homework folder.
Professor,
Yes.
can I send my homework right now?
Just post it to the thing, yeah.
Okay, thank you.
Professor, where is the review sheet? What week?
It's in the homework folder. It just
Oh, okay. I got it.
you'll see it there. It's not in a week, just below homework 9 and 10.